Hey Year 7s, let's take up Assessment 6. Mostly we're looking at just angle theory and linear sequences. So here we got the full turn and a triangle. I'm giving away the rules right now, but remember that we were talking about what was expected to be seen in your working. The first thing you need to write is the rule, then you need to write the equation, and then you need to rearrange and solve that. So that's what we're going to do right now. So looking to find out angle A, you should see that the rule is that it's in a full turn. A is in a full turn here with this 310 degrees. And you know that angles in a full turn should add to 360. So my rule is a full turn equals 360. My equation, the angles that are in this full turn, A and 310, need to add to 360, which means A on its own, moving the 310 to the other side, will be 360 minus 310, which is 50. So I've got A is 50. Next, we want to work out what B is, and the rule that's going to help us to find B is that it's inside this triangle. I know that the interior angle sum of a triangle is 180 degrees. So I'm going to write the rule. Interior angle sum of a triangle is 180 degrees. And then I'm going to write the equation, and that is that these angles add up to 180. So A plus B plus 65 equals 180. Now I already know what A is, I just worked it out. So I can put that value into my formula here, or my equation. That's going to be 50 plus B plus 65 equals 180. And to find out what B is, let's simplify this a bit and then get B on its own. So the 50 plus the 65 makes 115. So B plus 115 is 180. And B on its own, I'll need to move that 115 to the other side. And that's 180 minus 115. B is 65. Okay, now this is an isosceles triangle. True or false? Well, we know that isosceles triangles have two equal angles and two equal sides. I can clearly see that A is not equal to B. However, nowhere does it say that these have to be the two equal angles. B could be equal to 65, and it is. So those are the two equal angles. It is an isosceles triangle. True. Next, triangles and straight lines. Okay, hopefully I didn't need to tell you that. You can see here that we've got a triangle and we've got a straight line. So those are the rules that we're going to use. Here I've even started by writing out an equation for you, but I've missed out some things. Something that adds to 180 degrees. What rule could that be? It could be a straight line, because a straight line adds to 180, but those are three angles that add to 180. I don't see three angles on this straight line. So that must be the triangle. Angles in a triangle add to 180. Interior angle of a triangle sum. And now let's write that equation. I'm showing my working over here on my own to see if I can work it out for myself. Then I'll fill in the blanks. So the interior angles of this triangle are 2A plus the square, that means 90 degrees, plus 3A equals 180. So I can simplify this. I'm trying to figure out what A is, and luckily this is an equation that only has one letter in it, and it's the same letter. 2A and 3A, those are like terms. I can group those together and make that a single term, which is just 5A. 2A plus 3A makes 5A. And I've sent my 90 over here, which was plus, across to the other side. So it's minus, just so that I can try and get my 5A on its own, so I can find out what A is. 180 minus 90, that's 90. So I'm going to do A is equal to 90 divided by the 5. See, I've moved my 5 that was multiplying by the A to the other side, and now it's dividing. Right, so A must be, oops, I haven't worked that out yet. So 2A plus something plus 3A equals 180. That something must have been the 90. Next, I've grouped my 2A and my 3A together, so the number in front of the A should be 5A. And this over here, I've taken my 90 to the other side. I can see it's no longer there, so it's going to be minus 90 over here. And finally, to get A by itself, I got rid of that 5. It was multiplying by the A, so I divided it. So here I've got 90, because 180 minus the 90 is 90, and I'm dividing by the 5. Right, so I've got A on its own now. What's its value? 90 divided by 5? A must be 18. Now, knowing that A is 18 is really going to help me with this next part. Work out the size of angle 3A. Here's angle 3A. And 3A just means 3 times A. I know what A is, it's 18. So 3A is going to be 3 times 18, which is 54. So 3A is 54, that's this angle down here, 54. Now finally work out the size of angle B. Once again, this is triangles and straight lines. I've already used the triangles to help me figure out what A is. Now to find B, I can see it lies on a straight line with the angle 3A. Angles on a straight line add up to 180. That's my rule. So let's me write an equation. The angles that are on this straight line are 3A and B. So 3A plus B equals 180. I know what 3A is. I've already worked it out up here. It's 54. So if I just plug that in there, instead of the 3A, I put 54. Now I've got an equation where B is the only letter I don't know. So let's get it by itself. B equals 180. It was plus 54 over here, so I'll pick it over here, and it'll be minus 54. So B equals 126. Next, can we be sure that these lines, the blue lines, are parallel? Yes or no? Now, I can work out what A, B, and C is. I could use parallel line rules, but I'm not sure these lines are parallel. So let's use some other rules. Here I can see I've got a straight line. So I use that straight line to work out what A is. I figured it out because A plus 122 should add to 180, in which case A must be 180 minus 122, which is 58. I can also work out what B is. I could use some parallel line rules if I knew these lines were parallel, but I don't. So I'm just going to use another straight line. See this green line I've drawn in here is a straight line, which means that B needs to add with 22 to make 180 degrees. So once again, B is equal to 180 minus the 122, which leaves me with 58. Now, this is looking pretty good so far because I've seen these numbers before, 58, 58, 58. What about C? How am I going to find C? I'm not going to use the parallel lines because I don't know for sure that they are parallel, but I can use a straight line. This blue line here is clearly a straight line, which means 58 plus C need to add to make 180. So that means that C on its own must be equal to 180 minus the 58, and that leaves me with 122. So having worked out all of these angles, I should be able to see if there are any F patterns, C pattern, or Z patterns. Remember, C patterns, these angles here inside, they're interior angles inside the parallel lines, need to add to 180, do they? Yes, they do. And these angles here, the ones that I'm tracing now, the 58 degrees up there, and angle B down here, that makes a Z pattern. Those angles are alternate angles and they should be equal. Are they equal? Yes, they are. B is 58. And F patterns. This 58 degrees up here makes a backwards, sort of sideways F with the angle A down there. Are those two angles corresponding? Are they equal? Yes, they are. A is equal to 58. And we also have another F pattern over here with this angle C up here. Goes all the way down to the angle 122 down there. Again, it's sort of at an angle, but that is an F pattern. Are C and 122 corresponding angles? Are they the same? Yes, they are. So I am sure that these two lines are parallel because they have all of these parallel line rules at work. The F pattern, the C pattern, and the Z pattern. Yes. Now, angles and types of triangles. To give you a really good hint to start this out, I asked you what types of triangles they are, and I told you to look at the markings on the lines. For a triangle, the red triangle here, you've got little markings on all of the sides, which means they're all equal. Now you're going to have to learn the spelling for this because the computer doesn't mark it correct if it's not correctly spelled. Equilateral. Okay? And B, the blue triangle here, like the red triangle, it's got some markings as well, but not on all of the sides, only on two of them. That makes it an isosceles triangle. Again, the spelling is important. I-S-O-S-C-E-L-E-S, isosceles. So if this triangle has all of the sides equal, it must have all of the angles equal. If this side has two of the sides equal, this triangle, then it should have two of the angles equal. I'm looking at it, I know it's not to scale, but B does not look the same as C. So which angles look the same? This one down here and this one up here. Okay, the two angles that are not where the two equal sides join. Right, so let's work out A, B, and C. using the rules that I've just pointed out to you here. Angle A is inside an equilateral triangle. Now we know the angles of any triangle add to 180, but in this triangle in specific, all of the angles are the same. So I'm going to start with the interior angle sum. It adds to 180. But the angles inside this triangle that adds 180 are A, this would be the same as A, and this would be the same as A. There are three angles which are the same. So I'm going to write 3 A's make 180, which means 1A by itself would be equal to 180 divided by 3, which is 60. A is 60 degrees. Next we've got angle B, and it makes a straight line with angle A. So angles in a straight line add to 180. The angles that we're talking about are A and B, so A plus B make 180, and I already know that A is 60. So I'll go ahead and substitute that in here. 60 plus B equals 180. So B on its own, I'll need to send the 60 across to the other side. Here it was plus, there it'll be minus. B equals 180 minus 60, which is 120. So I've got A is 60 and B is 120. Let's go on to C. Now, angle C is a little bit more difficult because it's in an isosceles triangle. It's not equilateral and it's not a straight line, but it is a triangle. The angles of the triangle add to 180. And in an isosceles triangle, 2 of those angles are the same. Not 3, like in A, but 2. And the 2 angles are not the B and the C, but the C and some other angle. So I'm going to call that C as well. So when I say the interior angles add to 180, I'm going to say that it's 2 C angles and a B angle that add to 180. 2C plus B equals 180. So if I want to know what C is, I already know what B is. If I want to know what C is, I need it on its own. Let's go ahead and plug B in here for a minute. So B is 120. So 2C's plus 120 makes 180. And to get C on its own, we'll need to move that 120 to the other side. So 2C equals 180 minus 120. To get the C really on its own, let's simplify that. 180 minus 120 is 60. Let's get rid of the 2 now. C is equal to 60 divided by that 2. The 2 was multiplying, so we do the opposite, we divide. And C is equal to 30 degrees. So I've got A is 60, B is 120, and C is 30. That should help us to answer this next question. And don't just guess, just because it's true or false, don't think I have a 50-50 chance. Let's think about this. Is the red and blue triangle together a right angle triangle? Does this make a right angle triangle? Well, I know this angle over here is the same as angle A, so that's 60 degrees. That's not a right angle. I know angle over here, C that we just worked out, is 30 degrees. That's not a right angle. The third angle on this triangle is this one up here, which is partly this red angle and partly this blue angle. And this is an equilateral triangle, so that means that this angle here is the same as A is 60, and this triangle here is isosceles, so this angle here is the same as C, it's 30, and 60 plus 30, what does that make? 90, it's a right angle. So it's true, it is a right angle triangle. Next, straight lines and interior and exterior angles. So here we have a triangle that was formed from 3 straight lines drawn together. Work out the labeled angles. First of all, angle A. I hope you can see that angle A lies on a straight line with this 115. So A plus 115 should make 180. In which case A on its own would be equal to 180 minus the 115, which makes 65. For B, I hope you see that B, A, and 87 make a triangle. Those are the interior angles of the triangle, so they must add to 180. So I'm writing my rule, I'm writing my equation. I already know that A is 65, so B on its own would be equal to 180 minus the sum of 87 and 65. So B is 28. Next, we should see that C lies on a straight line with B, which means that those two add up to 180. So I'll write my rule, the straight line. I'll write my equation, B plus C makes 180. And then I'm going to solve that equation. If I already know that B is 28, then C must be equal to 180 minus that 28. So C is 152. Now D, I see down here, is on a straight line with the 87. So the rule is the same, it's a straight line. But it's D and 87 that add to 180. So D on its own would be equal to 180 minus that 87. That's 93. So I've got all of my angles here, and I think that went smoothly for the assessment. The confusing bit, I think, came down here. Now I explained what interior angles are and what exterior angles are on the diagram. And then I asked what the interior angles add up to. Well, that's A, B, and 87. These angles here. I already know that A is 65, B is 28, and 87, well, is 87. That adds up to 180 degrees. And that should be something that you know, because these are the interior angles of a triangle. They should add to 180. So this was really a check for you to see if you got your answers right up here. Next, the exterior angles. The exterior angles, as I said here, are C, this angle here, D, and 115. And you've already worked out that C is 152, D is 93. So adding those together, that gives you 360. And while you know that the interior angles of any triangle always add to 180, you will be learning that exterior angles of any polygon, not just triangles, any polygon, will add to 360. But we'll go over that a little bit in the future. Finally, linear sequences. A lot of you are getting a lot better at this. We definitely are getting the idea, but some of you are still struggling. So let's go over this one last one. Look at the numbers in the pattern and see if you can find the next two numbers. The numbers in the pattern are definitely going down in value. So I've got a negative common difference. How much is it going down by? I hope you notice it's going down by 6. I can clearly see that from 6 to 0. It's gone down by 6. So let's keep going down by 6. Next number will be negative 6, and then the following number, negative 12. Okay? As I said, if it's going down by some value, then the common difference is a negative number. And we said that it was going down by 6's, so it's negative 6n. But it doesn't start with negative 6. It starts with 18, which is much higher than the negative 6 times table. I need to add something quite big onto this to turn it into 18. Or the rule that a lot of people have found helpful is to think, okay, this is going down by 6's. What would the number before the 18 have been? Before I took away 6, what comes before 18? So 6 more than 18, that would have been 24. Okay, try that out with a couple of these values. When n is equal to 1, negative 6 times 1 is negative 6, plus 24 does give you the first term. Term number 1 is 18. When n is 2, do negative 6 times 2, that's negative 12. Negative 12 plus 24, that does give you the second term, 12. That's term number 2. So when I replace the n with the term number, the position number, it gives me the value of the number in that position. So when n is 3, negative 6 times 3 is negative 18, plus 24 gives me 6, the third term, term number 3. Okay? Hopefully this is becoming a bit clearer for some of you. A lot of you are doing really well and should be very proud. And if you're still struggling, don't be ashamed to ask for help.